Hey everyone, and welcome to a new video on this channel. I wrote a blog post the other day about Draft v2 on AKS, and Draft v2 is basically an open source project that aims to make things easier for developers that want to get their applications up and running on Kubernetes. Now, instead of reading that article, this video is here to show you how it works in practice. So let's take a look, shall we? Let's look at Draft 2 and how it works with a new empty project, just my code and nothing else. In this case, it's a Go code, and I have a makefile in this repo that contains the command to build my code without containers. So when I run make build, I should normally get an app, an executable, which is just a file called app, and the source code I'm compiling from is all in the cmd/app folder. So here you find the app executable. Of course, we're running on Linux here, and I can just run this app. Now the app is exposing a web server on a port. The default port is 8080. If you want to change that, you can of course set the port before you run the actual app. And when I do so, I see indeed that maybe I should put an equal sign in between. When I do so, I can indeed see that my server is spinning up, starting the web server on port 9999. So that's great. I'm going to Control C out of this and clear the screen. We know that the application is working. Now, I want to containerize this app and run this on Kubernetes. The problem is I don't have a Docker file. So how do I get this Docker file? Well, I can easily create a Docker file myself or Go, which is a bit of Googling, and I'll find it, right? But you can also use the AKS and then draft create command. So the draft create command will help you create a Docker file, but also manifests for your code to install your application on Kubernetes. Now, this command downloads the draft CLI, and the draft CLI will be run for you. So this is just a wrapper around the draft CLI executable that you will run eventually. So when I run this command here, indeed, there's something that starts first, and that is a language detection. So draft is going to try and find what kind of language are you using, and then based on the language it finds, it's going to propose a Docker file. So here Go was detected. I use modules. Then he asks, well, what kind of port are you actually exposing in the application? Because that port will be set also in the Docker file and things like that. So I'm going to enter 8080 here. That's the default port, as you have seen. And then he asks, what kind of deployment type are you going to do? Now, if in production you're going to work with something like Helm, you then recommend that now in this development phase that you also use Helm. So I'm going to select Helm, but the other options are plain Kubernetes manifests or Kubernetes manifests that you deploy using Kustomize configurations. I'm going to select Helm here, and Helm also needs to know a few things, like the templates that Helm generates, like my service YAML. It needs to know what the port is that my application exposes. And I have to have a name as well. That's going to be used in the Helm chart. I'm going to call this Super API. And this actually does the creation of all these artifacts. And it says the next step is to set up GitHub for you. So the setup GitHub command that you see over here. Now that's for in a moment. Let's first see what happened. The first thing we have is a Docker file. Now this Docker file is going to be a basic Docker file. It's going to be a quite large container image because they're using the Golang image, and it's not a two-stage Docker build process here. What I would normally do is have a second stage underneath here, and then maybe say from Alpine, or maybe say I'm going to work with the scratch image, which is 0 bytes, right? And then work from there. And then, for example, say something like copy and then from, and then the stage name. Stage name would be indeed, I think it's stage 0 in this case. And I could then say I'm going to copy the app from Go bin. Right, so I'm going to say I'm going to copy Go bin app, to Go bin app, or to just to copy it to the root of the scratch folder. So when you do that, you would have a two-stage commit here, and you would have a much smaller image. So I would recommend that it's something that you do. So I'm going to actually do this. and save this here and see if I made the correct changes here. You see some squiggly lines here as well, because I also installed HadoLint, and HadoLint is a linter for Dockerfiles, and it will also warn me about certain things that I maybe better should not do. Now, this is one thing, but there's another error in this which will not work. If you look at my make file, the go build phase, for example, it says, yeah, here are my sources. What draft thinks is that my sources are in the root of this folder. That's not the case. What I'm going to do is I'm going to just copy this here, and I'm going to replace this line, so the run go build, I'm going to replace this with my own build line that I know works because I already tested that a moment ago. So, okay, for some reason, there's some weird stuff happening here in my terminal. So I'm going to go back here. I'm going to delete this. So that should normally work. This is something that you normally would want to test on your local machine. So although draft does not require you to have Docker locally, because container images will be built in the cloud using Azure Container Registry, it's of course recommended that you do a build yourself on your local machine and see how far you get with that. So I'm going to run Docker build here. I'm going to call my image, so I'm going to tag it, I'm going to call it draft, and then draft super. I'm going to build from the local folder, so use the Dockerfile in the local current folder, and let's see what this does. Maybe I made some mistakes in my modifications to the Dockerfile, so let's see what's coming out of this. This will take some time, although I did run this a couple of times before already, so it might not take as much time as normal, but still I'm going to pause this a bit, and when it's finished, coming back to you. Then afterwards, when you have built your Docker image, you can try to run it. I did this here with docker run draft super, and what do I see? Of course, I forgot to have a command. Indeed, I don't need this here in my first one. I need this in the second one. So I'm going to say, okay, what's the command? The command is you're going to run app from the root. So I'm going to save this here and then try again. I'm going to build the container again. That should normally be going quite quickly, and then do a docker run draft super and then see if that works. And yes, it works. So what we have done now is we have modified the Dockerfile that draft2 has proposed a little bit. Draft cannot know it all, right? So we had to put our own source code where the sources are. We had to change that. I also modified the way the build is done a little bit. It's of course also up to you. You're the developer. You can of course do that for your own code much better than a generic tool can do this for you. And then I also made it a two-stage Docker build, so I have a much smaller resulting image that does still work. If you look at Docker images here and then or Docker image list, if I look at the image that I just made, draft super, it's actually quite small. It's only 29.5 megabytes. It would have been over a gigabyte if I wouldn't have added these 3 lines at the end. That's the first step. We have our Dockerfile here. That's great. But then we also need our Helm chart. The Helm chart that draft2 has proposed is created in the charts folder. And in the templates folder, you'll find deployment YAML, namespace YAML, and service YAML. So it generates this for you. And of course, in service YAML, you told draft that you use port 8080. So somewhere that port must be in there. Yeah, the target port is here in values container port. Well, what later will be done in the workflow for GitHub, this production YAML will be used. And here you will have all this information filled in for you. For now, I think it is somewhere in the, let's see, container port 88. So for now, it's in the values YAML. I think, yeah, that's the default port basically. And later they will add additional values coming from production YAML to on top of the default values that are provided in the chart. But this here is coming from the answer you gave earlier when you created the Helm chart. What you can also see is if you go to helpers TPL, you see here all these things like super API name and so on. You provided draft with the name of your application, super API, and that is used inside the Helm chart in several places. Now, of course, this doesn't deploy anything. So we now have to make sure we can actually use GitHub. We can authenticate with GitHub to Azure, and we create a workflow in GitHub that contains GitHub Actions. Let's see how that works. So now it's time for step 2. We're going to set up GitHub to make sure that we can authenticate properly to our Azure environment. So we're going to use AKS draft and then set up GitHub Actions, so GH here. And again, this will ask you some questions. It will want to have an app registration name. That's going to be needed because we want to be able to send a GitHub token to Azure AD, and then there will be an app will be responsible for accepting that token basically, and then changing it for an Azure AD token. So an app registration will have to be created in your Azure Active Directory. I'm going to give it the name Draft Super. Now know that I already created this app registration, so it will try to create it later. It will see it already exists and will error out, but that's okay. I just want you to see the different questions that are going to be asked here. So we add this registration name. It will take some time. Then it will ask us for our subscription ID. So the subscription we're working in, where is my AKS cluster? And you already have to have an AKS cluster up and running somewhere, like a dev cluster, for instance. So we'll give this some time. Here we see that's my subscription ID. I'm going to use that one. It's the only one that I have. And then a resource group name. Now that's the important part here. This should be the resource group that contains your AKS cluster. And that's also where you should create in a later step an Azure Container Registry. In my case, that is RGAKS. The reason you enter a resource group name here is that the service principal that's created due to the app registration that you create, the service principal is going to get contributor role on this resource group. That will ensure that the workflow we're going to create later will be able to manipulate your AKS cluster, connect to it, but also modify things in your Azure Container Registry in that resource group. So be sure that you use that one, the existing one that contains AKS. There should not be a new group or a new empty group or something like that. Well, it could be, but then you have to deploy your AKS cluster and your ACR into that new resource group. So I'm going to give it this name. And then, of course, things have to be created on the GitHub side as well. A couple of secrets have to be created in your repo. A secret, for example, that contains your subscription ID, but also your tenant ID and so on. And also the ID of the app registration that you're creating. In my case, that is gbake and then /draft super. You can see that here as well, but this is my clone. This is a clone of that one. So I'm going to do draft super here. And that's it. Of course, you have to ensure that you have admin rights, full access rights to that repo, so that you can create those secrets. Now, when I do this, it will say set up GitHub OIDC, so OpenID Connect. But then it will say, well, actually, that's not something that will work because the app already exists. So this is what the draft CLI says. And then, of course, the Azure CLI is going to give an error about this, that it could not execute the draft CLI successfully. So it looks maybe a little bit weird what you see here, but that's how it works today. Now, what has happened in the background is indeed that this app registration was created. So here is the app registration. It is draft super. And I already went to the certificates and secrets part, because there you'll see the federated credentials. And here the setup step has added 3 credentials. And you have to be really specific in what kind of things GitHub can ask an Azure AD token for. So in this case, they say, well, we're going to create a federated credential that can be used when you do pull requests on your repo. But also when you're going to do pushes to master or main. In my case, I created my GitHub repo with the command line, and for some reason it still defaults to master, which is a bit weird, but okay. He's adding master and main in this case. Now you'll probably see something weird here, because when you look at the main, it says, well, actually, we refer to a draft branch here. Well, that's something I modified in this app, because if you look at my code, note that I'm working in a branch called draft. And when I do a push to draft, I want to make sure I also get a correct Azure AD token from Azure. That's why I modified the by default created federated credential for main. I modified it to draft. Now, what is in this? If you click on this, you will see indeed that this is a supported scenario. Azure AD has specific support for this kind of federated credential scenario with GitHub Actions. There are other ones as well. For example, Kubernetes, right? Workload identity. In this case, we're using GitHub. And then you have to be really specific. And so the issuer of the GitHub tokens, yeah, it's coming from here. That's my organization in GitHub, my repo. It's coming from a branch in this case, and the branch, it was main before. I put draft in there. And that's all. So what GitHub can now do, or what certain actions can now do when you run a GitHub workflow, is that action can then go to Azure AD and basically say, hey, here's my token coming from GitHub. And I'm, for example, I am subject this one over here. So when you do a push to draft, this will be the subject, and you'll get an Azure AD token instead. That's basically what that setup GH command is doing. Now, if you look in my repo, then what you'll be able to see there is that in the settings, when you go to the secrets and we have the actions secrets, you'll see that there are 3 repository secrets defined here. That's also done by this setup GH option. So the Azure client ID of the app that we just seen, so the app registration, your subscription ID is there, and then the tenant ID is there. These values will be used later by the Azure login action in the workflow to properly use the OIDC integration and get a token to authenticate to Azure. That means that now we have properly set up our GitHub environment, so we are ready to create a workflow. To generate the workflow, we're going to use another command here, that is AKS draft, and then the generate workflow command. So let's just run this and see what happens. Well, in this case, he's asking for a container registry name. If I go back to my organization here and I go to my Kubernetes services, this is actually my cluster draft here. Well, in that resource group of the cluster, I deployed this container registry draft 7787. So I'm going to copy this here. Yeah. So that's the container registry name, and be aware that you use the short name here. So don't put .azurecr.io behind this name. Also note that draft doesn't create the container registry. You need to create the container registry. Then a name for your container, that's something that you choose. The build process will use that container name in the build. I'm just gonna call it Super API in this case. That's my container name. And of course, it needs to know where your resource group is living, because there will be connections made to the AKS cluster. They will use AKS get credentials. And of course, if you know that command has to also specify the resource group. So it's the same one that we used earlier, actually. So I'm going to use RG-AKS, and my cluster is called CLU and then draft. That's also used in the get credentials command, the cluster name here. And then where do I want to deploy from? Well, normally that would be like in a test scenario or something that probably will be main. But as I said, I'm working from a draft branch here. So I'm going to say, well, you know what, when I push directly to draft, so no pull request, no nothing, then I want the action to run. So the action will run when I push to draft in this case. So when I press enter here, the workflow is created. Just going to minimize this terminal over here and check out the workflow for a bit. So here you see that the workflow that they create. Now we're going to go quite quickly through that, so you have an idea of what is done. So you can see here, when you do pushes to the branch draft, it will run this workflow, and it sets some environment variables, right? So our container registry is set here. There's also a link to this production YAML in the charts. So in production YAML, they're going to use that as well in combination with the default values in values YAML to install the chart with all those values. The chart is in the charts folder. My cluster name is here. The container name is here. What also happens is that a pull secret will be created. So they will create a secret in Kubernetes that contains credentials to connect to ACR to be able to pull images, and of course my resource group. Now, there are a couple of jobs here. There's first of all a build image job. That build image job is just going to check out my code and then run the ACR build command. So the container image is built by ACR, quick task really. And of course we have to specify what's the name of the image going to be that we're going to build. So these environment variables are going to be used, and the tag for your image will be the GitHub SHA. So whenever you do a new push, the SHA will be different and you have different tags available to you. So this is actually the building and pushing. So be aware that building the container, that's not done on the GitHub runner. That's done by your Azure container registry. Now we have this this other job that will run concurrently, by the way, with the build task. That's the create secret task. So this basically is going to log into Azure, and here all the OIDC stuff happens. So this Azure login, especially this version that we're using here, if you just pass it the client ID, the subscription ID, and the tenant ID, well, it knows it will have to do this token exchange basically, right? And use the federated token approach to get a token from Azure AD using the OpenID Connect integration. So that is this action takes care of that. Now with that token that we then have, we can run Azure AKS set context. So this one is going to, watch out because I always get that help there. This one is going to make sure that you connect properly to your cluster. Yeah, what cluster? The cluster with this name in this resource group. That gives me access to my cluster. Now, what we want to do is now make sure we get access to our ACR credentials. So a couple of commands are run to turn on the admin mode of our Azure Container Registry and then retrieve the ACR username. So the ACR username here and the ACR password, and they are set as variables as well. So we can use that in the next step that creates a secret. So here a Kubernetes secret is created on the cluster that we set context to. And of course, this secret is using the values from the previous step to indeed set a secret that contains the username and password to the container registry. Now, this secret, if you look at this secret will be created here in the default namespace on your cluster. So if your workflow has run, check out the default namespace, the secret will be there. And then we have a deploy task basically, or a deploy job. But this deploy job will need build image and create secret to succeed. What does deploy do? Again, it checks out your code, of course, with the checkout action. It does the same login using OIDC, right? It's the same login here. We do the same AKS set context to connect to our AKS cluster, and then we do a deployment. Now, it doesn't actually run a Helm chart. It uses the bake action. The bake action has support for Helm, and it basically runs a Helm template command. So you get manifests out of the Helm chart, which is actually what Helm does, right? It creates a big manifest that contains all your templates with all their values in it. That's what the Kubernetes bake action is actually doing here. But it says also there are some override files, and this is actually this path to this production.yaml. And it also has some custom overrides here, replicas is too. Okay, don't worry too much about that. The output of this Kubernetes bake command is a manifest. So we're going to deploy these manifests. Yeah? Where do we get the manifests? Well, from the previous bake step, of course. There's a manifest bundle that we're going to apply to our cluster. And that's what the Kubernetes deploy action does. We do a deploy. Basically, we're going to do an apply here. But when we are going to apply these manifests, we also say, well, how should we actually pull the images from our container registry. We specify the image pull secret here by providing the secret name that should be used. And what we are also going to do, and that's of course important, in the manifests themselves, there is no version or something of your container image. So we're going to use the images option here with this task. The images option basically allows you to modify in the manifest bundle that we have here. We modify the image that's in there, and we make sure that we put the correct image reference in here, including the GitHub SHA that we use to save our image to Azure Container Registry. This is something that you would all have to do yourself, or a variation of this. And of course, it's great that Draft is able to create this for you. The question, of course, is, does this actually run? Well, there's only one way to find out. I will have to commit this here. I'm going to say, we're going to make sure that we commit this. We're gonna push it all, right? And then just sync up the changes. Now we give it some time to see what the GitHub action is doing, but I'll go to that GitHub action first. So if we go to our GitHub here and we go to actions, I have some from before, right? I already checked all of this out before, logically, but here is now the push it all action basically, or the action that runs based on the commit that we did. And there I can see indeed my build image and my create secret are running. And when these two are finished, the deploy step runs because it's dependent on these two. Let's give this some time and then get back to it. The actions are still running, but I can see that create secret already had great success. When I click on create secret, I can see what happened. Indeed, we were able to get the Kubernetes context. We got the ACR credentials, so we got all that information from ACR, and then we created that secret for pulling the image from ACR. If we are going to our K9S client, we can already do that. If you go to our K9S client here, I can actually go to my secrets in the default namespace. And what we'll see there is that, let's go to default first and then go to secrets, right? There I have the draft 7787 secret. So this one, the age, you can see it is only something around 80 seconds. When I decode this, so I do X over here, there I see that this is actually the Docker configuration that's in it. This will be used to authenticate to the Azure Container Registry. So we're not using Active Directory authentication here. And now we also see that build image succeeded. If I click on build image, you see, of course, here we did a build and push of the image to ACR. When we go to ACR, we can indeed see, if you refresh here, that there should be already a new image. I think it was already finished while I checked, or while I went on this page. So when I click here on this one, you can indeed see we created this today. Yeah, that's actually the time that is correct here. So this image has now been pushed. And here you see the Git SHA, the GitHub SHA that was used as the tag. If we go back here to our summary of the action, we see now that the deploy step is busy. So when I click on deploy, I can see and follow it along, and yeah, the baking is just done. So the bake deployment is done, and now we see indeed that the deployment steps are happening. When we go back to our overview summary, yeah, that is now green. That means that the deployment must have happened. And if I check here, if I check the pods, I can see here that indeed I have, in this case, only one pod running because I've overridden that in the production file. So that's not too important. I see here this release name super API. That's my pod. Don't worry about the other one, that's from something else. And if I go to the services, I see a service as well. I can see here the release name super API, service type load balancer, and I can actually access my service on this external IP over here. What I will also see is if I go to my namespaces, and here on the default namespace, and I ask for the YAML, what I also see is that we have this open service mesh IO sidecar injection enabled on this system. Open Service Mesh was indeed installed. That means also that this thing must have a sidecar as well. So yes, if I go to my pod here and if I enter this, I can see indeed that there's an Envoy sidecar in this pod. That means also that Open Service Mesh was enabled. And that's actually by default in the Helm chart that Draft creates. It sets this annotation at the namespace level so that every container I create or every pod I create will get this sidecar, this Envoy sidecar that then Open Service Mesh can use to do its magic, right? So basically that means that our workflow has succeeded. The only thing that we now have to do is just modify our code, right? Work on our code, see what is going on. We make changes, for example. In my case, I could say I want to modify something in my code here, and my code is here in the cmd main.go. Suppose I want to modify this default here, like the default port shouldn't be 8080, but something else or whatever. I can modify my code here, make sure I push this all to in this case, my draft branch, and it will be deployed to our cluster, get a new image and a new deployment to your cluster. So that's basically what Draft can do for you, step by step. That is looking at, okay, what is your code, generate a Dockerfile, then make sure that there are manifests, for example, a Helm chart, and then enable GitHub OIDC for authentication, and then create a workflow that you can use then to push your changes to Kubernetes whenever you make changes to your code during your development cycle. I hope this was useful. See you some other time. Bye bye.